All right, let's talk about cloud security. Most people don't understand what it is. If you're trying to break into tech or you're already working in IT, you've heard this term constantly. But here's the problem. Most explanations are loaded with buzzwords, so you're not actually learning anything or understanding anything. You got zero trust, defense in depth, shared responsibility model. And if you're new, you're sitting there thinking, okay, but what does that actually mean for me? So let me break it down. What cloud security is, why companies are desperate for people who understand it, and what you need to know in 2026. Because once you understand how the systems work, you stop feeling left behind. All right, cloud security is keeping your data, applications, and systems safe when they're running in the cloud. But let's back up, because what does cloud even mean? The cloud is just renting space on someone else's servers instead of buying and maintaining your own. So when you use AWS, Azure, or GCP, you're using their infrastructure. So cloud security is making sure that when your stuff is running on rented infrastructure, it stays protected. Now here's where it gets interesting. So back in the day, if you wanted to run a website or store data, you just buy physical servers. You lock them in a room, you control who had access. Security was pretty straightforward because everything was in one space, one place. Your application could be running on 10 to 12 different services, and you're sharing infrastructure with thousands of other companies. That's why cloud security exists. The attack surface just got way bigger, and the old security playbook doesn't work anymore. It's outdated. So now here's the thing that trips people up. When you move to the cloud, security becomes what's called a shared responsibility. This is critical, so pay attention. If you don't understand it, you're going to make mistakes that cost you. So here's how it works. The cloud provider, AWS, Azure, GCP, they're responsible for security of the cloud. That means the physical data centers, servers, network infrastructure, all that stuff is on them. But you're responsible for security in the cloud. That means your data, your applications, who has access to what, how you configure your services. And this is where most breaches happen. Think about Capital One. Over 100 million customer records exposed. AWS didn't get hacked. Someone on Capital One's team misconfigured a firewall rule. The infrastructure was secure. The configuration was not secure. And that's the shared responsibility model. Cloud provider secures the infrastructure, and you secure everything you put on the infrastructure. So what does cloud security actually involve? Let me break down the 3 core areas for you. First, you have Identity and Access Management, IAM. This is all about who has access to what. And it's the foundation of everything, because in the cloud, you're not just managing people. You have to manage services, you have to manage applications, automated processes. All of them need permissions to do their job. The rule is least privilege. Give the minimum access needed to get the job done. And here's exactly why that matters. So let's say someone needs access to deploy code. You give them admin rights because it's faster. Now they can delete your entire production database by accident or on purpose. Or an attacker compromises that account and now they have access to everything. This is why IAM is the first thing you need to get right and understand. Because if you mess this up, nothing else matters, because the attacker already has the keys to the kingdom. So modern tools like AWS IAM Identity Center or Azure Entra ID help you manage this at scale. They let you centralize access control across multiple accounts and services, which matters when you're dealing with hundreds of users and thousands of different resources. So it's really important. Number 2, data protection. This is encryption, backups, and making sure your data doesn't end up where it shouldn't. And there's 2 types of encryption you need to know: encryption at rest and encryption in transit. At rest means your data is encrypted when it's stored. So if someone steals a hard drive or gains access to your storage, they can't read it without the encryption key. In transit means your data is encrypted when it's moving between services or the internet, like when it's traveling from your application to a database. This protects against someone intercepting that traffic. Both matter. And in 2026, this is baseline. So if you're not encrypting data, you're not meeting compliance requirements for those industries. Cloud providers give you the tools to manage this stuff. So you have AWS KMS, you have Azure Key Vault. They handle your encryption keys so you don't have to build your own key management system, which is a whole different beast. So it's easy to mess up. But here's the catch. Just because encryption is available doesn't mean it's turned on by default. You have to configure it. Someone creates a database, they forget to enable encryption, and now sensitive data is sitting there unprotected. But the same thing with S3 buckets. By default, they're private, but one wrong setting and your entire customer list is exposed in public. So you have to be careful. This has happened to major companies multiple times. So that's why understanding how these services work is more important than just knowing they exist. Number 3, network security. This is controlling how traffic flows inside and outside of your environment. So in the cloud, you're building virtual networks, VPCs for AWS, VNets in Azure, and you need to define what's public, what's private, and what can talk to what. Security groups act like firewalls, and they basically just control which ports are open and who can access them. And this matters because every open port is a potential entry point for an attacker. All right, for example, your web server needs to be accessible from the internet. So you open port 443 for HTTPS traffic, but your database should only be accessible from your application, not the public internet. And I've seen production databases exposed to the internet because someone opened port 3306 to test something and they forgot to close it. And once that's open, you got automated bots that are constantly scanning for it. They'll find it within minutes, sometimes seconds. So that's why network security isn't just about setting it up one time. It's about auditing, monitoring, and making sure nothing drifts over time as your infrastructure changes. Tools like AWS Security Hub or Azure Security Center, it's like a big dashboard that helps you track everything. They flag misconfigurations before they become breaches. They always scan your environment and alert you when something doesn't match your security policies. So why does all of this matter? Because cloud security is a business problem. When a breach happens, it's not just an IT issue. It's lawsuits, fines, customer trust gone, reputation gone, exposure. The average cost of a data breach last year was over $4 million. And most of those breaches came from misconfigurations, open S3 buckets, overly permissive IAM roles, database exposed to the internet, all things we discussed. And this is the thing, companies need people who understand this stuff. They need people who can explain to a non-technical executive why spending time on IAM policies matter, why encryption is mandatory. What happens when you get it wrong? That's the gap. And if you can feel it, you're valuable. All right, that's cloud security, identity and access management, data protection, network security. And if you're trying to learn this stuff, I got some resources that'll help you. I put together my Security Plus notes when I was studying for the Security Plus, and I built Proofstack, which generates cloud security projects, AI projects you can build for your resume and interviews. All of it's free. Just sign up for the Bite with Mike newsletter below. Links in the description, and I'll send everything over. And if this helped, just let me know in the comments. Drop a comment, hit subscribe, and I'll keep breaking this stuff down for you. All right, see you in the next one.